spirals, ellipticals, and irregulars based on literally their shape. Irregular shape is some galaxy that is yet to form a nice shape because it's probably made out of merging with another galaxy. We mentioned some examples of that if you're following my clips and lives and things like that. And then elliptical galaxies are galaxies in the shape of an ellipse. Ellipses can be of different types, of course, with different ellipticities. And then spirals are like our own galaxy. And we talked about our galaxy is quite a substantial galaxy. Not every galaxy is like our galaxy. Our galaxy has a lot of stuff. It has a lot of stars. It has a supermassive black hole. And its luminosity comes in a variety of wavelengths. So, for example, we've talked about our quite bright galactic center, where you get a lot of radiation in radio waves, in X-rays, and because we have a supermassive black hole, we're just making things accrete into it, as in it doesn't just eat up material from its surroundings in a straightforward way, where the material just shoots straight down into it and then is lost in the black hole forever, but it makes things accelerate and fall into it after doing a dance, where that dance makes us be able to see it in a very bright way. The accretion of material and all the acceleration of the material, and is what's emitting the synchrotron radiation and Compton and all these different processes of radiation from the material that's falling into the black hole. So that material falling into the black hole makes it very bright. But also, we have a ton of stars. We have a ton of stars. Not all the same stars. So I'm going to mention, I was talking to you about metal poor stars, or the first stars, and how stars were not always so metal rich. That's where I got started talking about our own galaxy, because even our own galaxy gives you a glimpse of that, gives you an idea for the diversity of stars that there really is in the universe. So, for example, let me finish the thought of where our galaxy has a ton of luminosity, of course, coming from the Galactic Center. Some galaxies that we talked about, remember, in a different live called active galaxies, those galaxies, the most brightness from those galaxies, the majority of the luminosity of those galaxies actually come from their galactic center. They have an active galactic nucleus. So those galaxies, that active galactic nucleus is basically competing with the luminosity of everything else put together, right? So when that happens, we call those active galaxies or active galactic nuclei. But when you have a galaxy like our own, which is a spiral normal galaxy, where we have a ton of radiation from the galactic center, but we also have a ton of luminosity coming from all the various stars we have a lot of stars. We have 200 billion stars in our galaxy, if I remember correctly. You can always double check that number. Then we call it just a normal spiral galaxy. We don't call it an active galactic nucleus. And the nice thing is, or the interesting thing is, that even in our own galaxy, we have both metal poor stars as well as metal rich stars. We actually looked at a picture of our galaxy and we saw there were all these different spiral arms, and some parts had the metal poor stars and some parts had the metal rich stars, actually. And so where are the metal poor stars in our own galaxy? In the halo. So our galaxy has three parts. We have the disk, the bulge, and the halo. The bulge has to do with the galactic center. And so I just spent a little bit of time talking about the galactic center already, but the halo is just like this big sphere that's all around our galaxy and goes way far. And that's where you'll find a ton of the older stars or the metal poor stars. So even in our own galaxy, there's all these different diversities.